Okay, so I guess I will go ahead and get started. Hi, Michael. So I'm going to be posting a link to where all of the material can be found from today's presentation. So this deck, as well as a sample notebook that we'll be walking through for the most part of the call. So this is primarily going to be a workshop. We'll spend a lot of time working within a notebook instead of through the slides. So I'll quickly try to get through the slides, and maybe we'll jump back and forth between the slides and the notebook, but it is a workshop, so feel free to interrupt me at any point, ask questions if you have them, or stop me if I'm moving too quickly. But that Google Drive will contain everything you'll need to replicate what we're walking through today. So I first want to just thank the conference for having me today. It's been let me share my screen. Oh, am I sharing? No. Okay. Are you able to see my slideshow? Yes. My slides?
Yes.
Okay, perfect. So yes, I wanted to thank the conference for having me today, as well as Jamil for helping make this happen. So she has been very supportive, and I definitely appreciate all that you have done, Jamil. So thank you for setting this up and letting me have the opportunity to speak today. So a little about myself. So my name's Andy Neville. I am a data scientist / economist at KPMG. If you're not familiar with KPMG, it primarily is an accounting firm. You may, if you follow golf, you know that Phil Mickelson was probably our most prominent kind of person that we had. He always wore the KPMG hat, but that has since been, I guess, in the last 2 weeks, no longer the case, but that's kind of the KPMG brand. I'm an economist by training, so I went to school for economics and applied economics for grad school. And then in the last, I would say 5 or 6 years, I've kind of transitioned more from an economist to what we would say is a data scientist within the field. I was telling Jamil just now that a lot of my work recently has been in fraud analytics and detecting fraudulent activity, building models for various states to detect fraud within their COVID relief programs, making sure the money gets to its intended audience or intended people who need it, and not fraudulent actors. I've also done work with Department of State, Homeland Security. So just a few of my other clients that I help primarily, again, with fraud detection. But recently I've been interested in, I guess, building machine learning models for assisting in collecting data on representation, and in this instance, representation within state legislatures. So I'm going to be talking about different techniques that I use in helping to kind of label data in this manner. And again, we'll be walking through code to kind of work through some of these techniques, such as if you've ever worked with image classifiers, or if you're aware of them, being able to take images and build a machine learning model to identify what is contained within the image. So for this presentation, we'll be building an image classifier to identify the race or ethnicity of state legislators. So that's one of the kind of problems that we'll be working through today. And then on top of that, we'll also briefly cover some natural language processing techniques. So we'll be able to also build a text classification model that you could use if you were trying to identify gender or sexual orientation through, let's say, biographies, being able to kind of build a model around text. So that's a little bit of background of what we're going to be covering today. As I mentioned, I do have the the code and this deck in the chat. So if you don't have it yet, just if you're unable to see the link, please just put that in the chat and we'll post it again. Okay, but yeah, so here's the link again. It's also in the chat. So I would encourage you, if you want to follow along, to go ahead and download that now. I guess one other housekeeping matter. So this presentation will be in Python. Everything that you're able to do, or that we'll go through today, can be done in R, but the code examples will be in Python. Okay, so what are the benefits of using machine learning to do some of your data labeling? These are kind of the three that I see as being the kind of the largest benefits here, but there's certainly plenty of others. But one is repeatable results. So with building a machine learning model, if that is doing the labeling for you, you can pretty much guarantee that every time you run this model, it's going to have the same predictions for you. So you're not going to come across the same type of issues where if you have multiple people doing the different labeling for you, that different people could have different answers. Or even yourself, if you were to kind of look at data, label it one day, and then come back a couple weeks later and relook at something, you yourself may have a different answer for how you would label that. And with machine learning, you've kind of eliminated that issue where it will programmatically always assign the same labels regardless of when you're running it, assuming that you haven't retrained your model or made any other changes. But if you're just strictly using the same serialized model to do your labeling, it's going to always guarantee the same results for you. The second point here is that machine learning models are exponentially faster than doing this manually. And you'll quickly see this in the course of this presentation, because we'll be able to label over 200 images within a matter of 2 minutes. So just it's going to increase the ability of time labeling your data, and so that's going to give you more time to work through your problem and study the data afterward and see whether there's trends, writing your report, writing a paper. It's going to provide you more time with doing that and less time with the labeling aspect, which generally is very time consuming. So using machine learning can help speed that up. And then the last issue, or last kind of benefit here, is somewhat related to the first one, and that's machine learning models will provide you with probability estimates. So not only are you able to make a prediction on your labeled data, but it's actually going to also assign a probability of that estimate. So you're going to be able to build confidence intervals. You'll be able to see which predictions are kind of borderline that may require more manual kind of review. You'll be able to build in different logic for identifying things that require further attention based on these probability estimates. And that's just another benefit of saying how confident you are in that prediction. And that's something that's going to be very hard for a human to be able to place a probability to their assigned label. So these are the three major benefits that I see to using machine learning. Like I said, there's probably 1,000 more different reasons why it could be beneficial to you, but these were the high ones. And then on the right here, if just kind of a plug to some of the work I've done, this is a page within legislatordiversity.com, which is the project that I have been working on for the past 2 years, which kind of leverage these techniques. You'll be able to build data sets like this where you can label state legislators based on their race and ethnicity or their identified gender. You'll be able to do this quickly using these type of models. I do want this to be somewhat conversational. So if there's any questions here, I'll pause for a moment, but yes, please feel free to interrupt me as needed. Okay. Okay, so the first thing we're going to cover today is just a general refresher on how to web scrape in order to collect your data. So again, automation is your friend here. Web scraping can make that manual collection much less time consuming. And so we're going to briefly just cover how you can web scrape different types of sites. And we're going to walk through 2 different examples of how to do this. But whenever you're going to do a web scraping kind of problem, you're trying to solve a web scraping or a data collection problem, your best friend for kind of working through how the page is designed within the site you're trying to scrape is using the Inspect Developer tool. And so most applications of web browsers, whether it's Google Chrome, Internet Explorer, whatever your preference is, they'll have some sort of Inspect Developer tool to help you identify and pull the relevant information that you need or are looking to collect. And so I'm going to just go ahead and I'm going to stop presenting here. And I'm going to switch over to my screen. Okay, so the first site we're going to look at is Mississippi's House of Representatives for state legislators. So you'll notice quickly, is everyone able to, sorry, I want to just make sure I'm still sharing my screen. Are you able to see the, okay,
yep, you
perfect.
can see.
So this is a fairly basic web page. It just has a list of the different representatives within the Mississippi state legislator. And it's just a name with a link to the various pages. So this is a simple page that will be able to quickly scrape each of the individual legislators and not only scrape just their name, but we're going to be able to then go up to the next page and scrape some of this other information within it. So you'll see here it has education, occupation. There's a short description. We'll call this a biography, as well as district information, party affiliation, etc. And so you'll also notice here that it's an XML site. So this is a little different. It's again a kind of an old school way of designing a web page, but it does have some benefits for web scraping, and it actually will tokenize a lot of the elements on the page for you, and so you'll be able to quickly scrape that information based on the tags that are assigned to the elements on the page.
Can I ask a quick question here?
Yeah.
So the equivalent in R was like a crawler. So does this like crawl? I see, because R's web scraping that I've done, it's usually just the one page. So this crawls across pages, like all of the links.
It will. So yes, there are web crawler packages in Python that are certainly out there that make some of what we're going to cover a little easier for you, and you won't have to get into some of these details. But I learned how to web scrape, I guess, 10 years ago. So I'm just using the most simplest of packages, and we'll go over that in a minute. But it's you're going to be able to kind of tailor it exactly to the information you need. I'm not as familiar with some of these other web scraping packages out there, but yes, if you have another one in mind, again, this might not be as necessary to kind of learn some of these aspects of it, but there are certainly web scraping packages out there in Python as well. Thank you for that, Jamil. But so if I go ahead and I just kind of right click on the page and then I go to inspect here, it's going to have a few different elements on the page here. So this is going to kind of just show you the HTML tags of the web page itself. We're going to skip that for now and just go over to the network tab. And this is going to kind of tell you whether, when you're making a request to the website, whether it requires a GET request or a POST request. And the main difference here is that in POST requests, the site is requiring you to provide information to it in order to determine what to send back. Whereas GET requests, it doesn't require any information sent to it in order to interact with the page. And so we can quickly find out what type of page this is. You'll see it's empty here at the moment. But if I go ahead and I kind of hold down on the refresh and just do an empty cache, this is just in case you've already looked at this page. Sometimes it's going to tell you different information here. But if I go to all, and here I can kind of see that it's generally, if it's an XML, you'll look in the document type here. And here, if I click on that XML, you can see this is a GET request. So I don't have to send any information to it in order to interact with this web page. So I'm going to switch over to the code now, and we're just going to quickly show how to kind of scrape that page of all the information we're looking for. So again, I am sharing this code if you just attended. So if it's in the chat if you want to download this for yourself. But this is a Jupyter notebook. If you're not familiar with it, this is Python code. And these are just some of the packages that we'll be using throughout the course of the exercise. If you don't have some of these packages installed already, you can just go ahead and comment out these lines here, and then that will install it for you. So if you don't have it installed at the time you're running this, just go ahead and comment out where it's being imported first, then uncomment the pip installs, and then you can then uncomment back out the packages and import them after you've installed everything. So for web scraping, for today's lesson, we're primarily going to use the request package. That's going to be how you interact with the site. And then to actually grab different things from the web page, we're going to use the LXML package. And then there's different classes or functions within that we're going to be using. So I'm going to go ahead and kickstart that. The next thing I'm going to do is I'm just going to set a working path to where I'm going to save this information within my local computer. So that's all I'm doing here is I'm just pointing to the directory that I'm currently working in, and then I'm going to go up one directory because this is my notebook code in here, and I just want to go to its parent directory because I'm going to save everything in the images directory. So I'm just telling it that my working folder is this parent directory, and then I'm going to save everything in the image folder. And the last thing I'm going to do, so this is going to be when we're actually doing the image classification here in a second. But this is just telling the computer or the program what kind of computing power your machine has. So for this, because I don't know if everyone will have access to GPU computing, we're just going to set this to CPU. But if you do have GPU computing on your computer, you can test that by uncommenting this line. And that's going to say, if you have GPU, set it to that, if not CPU. So just for the sake of this, I'm going to just default always have it be CPU. So it's going to take a little longer, but you'll find that with the number of images we'll go through in this, it's still within a matter of a minute. So it's not a huge constraint here. If you were running this on thousands of images, it would probably make more sense to try and do that on a GPU computer. Okay, so the next thing I want to do is I want to just create a data frame that's going to collect the information that I'm scraping. So I want to scrape the state name, the legislator's name, what branch they serve in, their party affiliation, and then I'm going to scrape their bio because we're going to also work on, again, an NLP model based on their bios in this workshop. The next thing, I just want to do some mapping. So this might not make a whole lot of sense yet, but this is how the information is actually displayed within the web page itself. So for when we go ahead and scrape Georgia, it's just coded by the first initial of the party, whereas in Mississippi, it's coded based on a numeric scheme, 0 being Democrat, 1 being Republican, and 2 being independent. So that's just a mapping dictionary that I'll use later on. And then lastly, here is just creating a function. So if people have nicknames that appear within quotes, I'm going to get rid of the nickname and just keep their full name without the nickname portion. So again, we're going to run this first on Mississippi. Here I'm just again telling it where to save those images. I'm defining the websites that I'm in, the URLs of the website that I want to scrape. So these are the base websites URL, so not the individual legislators. And then I'm just creating a temp URL that's going to be filled in by the legislator's name because that's how the web pages are structured for subsequent legislators. And now here's where I'm actually doing my web scraping. So I'm calling the website here with the response. Then I'm going to kind of convert that into a element tree where it will have different tags for each of the various components. So it will have a tag for, let's say, the link that you want to scrape, the name of the legislator. It will have a tag for the party, etc. So this is just making it very easy to only grab the elements of that page that I want. And I'll quickly just kind of showcase what this kind of looks like. So I'm going to just print here, legislator. So this is, again, the main page of the website that just has a list of the names. I'm going to comment this out because it's doing a lot of other stuff that we don't need at the moment. And I'm going to just go ahead and run this. And as you can see here, so this is how that first page that we were looking at, these are the various elements on that page. So you'll see that it has links, it has the name and the link of every different representative within the state legislature of Mississippi. So it's very easy to grab these now because I want their page. I want to be sent to the legislator's individual page. So I'm going to just go ahead in my code here. I'm going to go ahead and just only proceed on if that element tag is a link. And then I'm going to take that URL and then I'm going to add it to my temp URL, which I kind of placed up here. And I'm going to put the actual name of the legislator within those curly brackets there so that I have the full page of each member of that legislature. Okay, so that's that. And then if I kind of keep going, so I'll uncomment. If I keep going here, the next thing I'm going to do once I get to the legislators page is there's now going to be a whole new set of tags. And so you'll see here, they'll have the legislator's name, their party, personal info, that's the biography, and the image name. So that's going to be the link to where the image is that I want to then scrape. So those are, it's going to be just like what we looked at below here, except it's going to be for the individual page. So there will be different tags, and it will also have tags for, like I said, occupation, education. So if you were interested in collecting that information as well, there'd be tags for grabbing all that. So I'm just going to go ahead and run this whole thing now. And I'm going to print. This is, again, grabbing everything we were looking for. And this is crawling all those pages for each of the individual members for both the House and the Senate of Mississippi. And if I come here, you can see that the images are being scraped very rapidly. So I'm quickly building a data set of the legislators' images that I can then use to build an image classifier. So I'm going to pause here because I'll let this run its course. Is there any questions so far? And then the next thing, we're just going to quickly go over Georgia, which is a little different of a website. But I'll pause here for questions on what I've done so far.
I have a question. Andy, can you hear?
Sure. I can, yeah.
Yeah, so well, I haven't ever done any web scraping, but I'm just curious. So all this data, so the images, the information on the other, like the race, ethnicity, and all of that stuff. I mean, can you code it to do that, to recognize the members?
Sorry, were you finished with the question? Sorry.
No, I was saying, can you add more information and specify it and put it on a spreadsheet and all that stuff?
Yeah, and we're going to walk through that in a moment. So right now, so this web page for so Mississippi doesn't have their race or ethnicity or their pronouns or that. Well, you can get it kind of out of the biography, but it's not kind of explicit on those things. So we'll go over how to kind of build an image classifier model to identify it based on the image, as well as the text on things like race and ethnicity or sexual orientation or gender identity. So it depends on the site, but or the state how much information they have up front. But this is assuming that that information is not disclosed. And so we're just going to grab as much information as we can to help build a model to kind of do the labeling based on the information we were able to grab.
Thank you.
Yep.
Do all the profiles list the member's faith?
They do, yeah.
That is super weird.
Yeah, so some states are a little harder than others. So like there are states out there that have the images within PDFs. And we're actually going to go over how to scrape PDF documents in the Georgia exercise. So Georgia, while we're waiting for that, if I just click on one of these legislators, Kimberly, you'll see that she has a biography that's in a PDF. And if I open that, we have all this text and image, and I'm going to show you how to scrape all this text from that PDF document to build into your model as well. Okay, so I think this probably is done running. Yes, so here is the results of that scraping the Mississippi website. So we have their state here. We have 175 members of both their Senate and their House, their party, and that biography here. In addition to that, we also again have in our images directory now, we have all of the images for all those legislators. So that again only took 2 minutes, I think, for it to run. So very quickly, where it was able to create a data set that you can then use to build models off of. So the next thing I want to do is I'm going to show you how to do that for Georgia, which is a little different of a website than Mississippi was. So I'm going to just set the state name parameter to Georgia so that the next block of code goes down that path instead of the Mississippi one. So again, this Georgia actually has an API that has all the information within it. So if you attempted to scrape directly from the API, if I tried to connect to this website, I'm actually going to quickly identify that it requires an authentication method. So some websites have better security than others. And it's just a check on whether it's a real person kind of looking at the page or a bot. And so you're able to actually mask that this is human activity by kind of using these page headers. So you're sending websites when a regular person is viewing it, it has certain information that it sends to the website to kind of show that it's a person and not a bot. And some of these are right here. So like what's the user agent? So this is being accepted as Chrome, Mozilla, Explorer, things like that. So that's just kind of where the request is coming from. So you're able to mask that when you're sending the kind of authenticate to the website. So if I tried running this right now, it's going to actually say that I couldn't authenticate because Georgia requires a new authorization code per attempt. So this is an old code here, as well as an old cookie. So when I go to Georgia, and again, this is not an XML page, so it's a little different of a website. But if I go ahead and I click the inspect tab again, so I right click on the page anywhere on the page, just to inspect. Here's again, just the HTML layout. I go over to the network tab. I have viewed this page before, so I don't want to take the cached version of it because that's not going to give me a new authentication code. So I want to just empty that cache to get it to recognize that this is the first time I'm viewing this page. And if I go over to the fetch XR HR section, so it was on all before, I'm just moving over one at the top here. And if I go down to the chamber, this is where the information is actually being sent to the site. And this is kind of viewing trial and error, or just looking at what the different kind of requests that are being submitted when you interact with the page. So you're just kind of working through them, but I know it's going to be in this one here. I see it's a GET request again, so I don't have to send the type of data I'm looking for. I don't have to say like, here's my username, here's my password. I don't have to provide any of that information. So I'm just using a GET request again. But if I scroll down, it has the request headers, and all of this information here is what you saw in this block of code. Most of it is static. It doesn't change. So you're never gonna have to kind of change. Anytime you were trying to scrape this on different days, you wouldn't have to change this basic kind of information. The only two you're gonna have to change or update per scrape is the cookie and the authorization key. So I'm just gonna go ahead. I'm gonna copy over the authorization key. I'm just gonna replace the one that I had in there. I'm going to do the same with the cookie. And again, I'm going to run this right now just so it's kind of doing it in the background while we talk through the rest of the code. So I've just replaced those two items. I'm going to go ahead and I'm going to enter. And so this is going to now start scraping the different pages within the House of Representatives and then the Senate as well. So again, unlike the Mississippi page, which just had the names on the home page, or landing page, if you will, this has the image itself. It has the name of the representative or senator, a link to their individual page, their party information, their district. Most of the stuff I wanted to collect is all on this home page. So if I didn't need any other information here, I wouldn't even have to kind of scrape the kind of individual pages of the different legislators. I could just stop at this single page, but I want the biography because we're building an NLP model as well. So I'm going to go ahead, I'm going to click on that. And I'm just going to identify like where on the page, how the biography appears. So I see it's in an H element. There's a tag here for biography. I probably will end up using that to identify where that is. So that's how I can quickly with the class information, the icon information. This is where on the page this biography is appearing. So I'm going to use that information there. I'm going to use the text tag, which calls it a biography. And then all I want to do, the actual link to the PDF is the parent of this. So once I find that information on the page, then I'm going to just go up a parent and grab the H reference for where the PDF document is saved. So here, again, I'm just looping through the Senate and the House URLs. I'm sending a response to the page, which provides those headers. So that this is unique from the previous request. It didn't require header information. And this is the URL for the one I'm scraping. So I give it the URL, I give them that authentication key, cookie key, and that's my initial response. And the return is actually a JSON object. So JSONs, if you haven't worked them in the past, they're a lot like dictionaries. So they're going to have keys and values. And here you can see that I have a full name key, which identifies the person's name. Then I'm going to just clean up that name again, removing nicknames, anything that might appear within quotes of the name. I just want their actual base name. I'm scraping the party. I'm going to, if it's not a 0 or 1, so if it's not Democrat or Republican, I'm just going to set it to 2, which is I'm going to classify as independent. I'm grabbing the individual legislator's URL, or sorry, for the photos. So this has a URL with where the photo is saved within their website. So I'm going to grab that URL for the image. And then I'm going to grab the bio information. So if I were to kind of work through all of the different individual pages, I'll notice that the bio information, the link to it is all structured the same. It has a last name, it has a hyphen, their first name, and then an ID. So an ID isn't the party ID, it's going to just be a numeric number that represents that legislator. So if I look up here, and if I were to just click that biography again, I can see that their ID is an 806, and this is actually, or Kimberly's ID is an 806, and so this ID is part of that JSON dictionary that is returned. So if I were to look through all of the different legislators, I'd see that again, it's their last name, hyphen, first name, hyphen, part or ID of how their number within the website. And they're all structured like that. So I know the base URL, and now I know how the PDF file names are saved. So I'm able to just quickly kind of create a default URL for that, insert in the key part of the information, which makes that URL unique. And then I'm using a package called My PDF to actually go ahead and open the PDF file, make it into a format that the program can read. And so now that once I have the file opened, I can then go ahead and scrape all the words within that document. So again, this isn't a URL that I'm scraping, it's a PDF document. And I'm just going ahead and I'm scraping all the words contained within that PDF file. And then I'm just joining them all together into one long sentence, which will be the legislator bio. One of your questions, Matthew, was whether all legislators have images. They do have images. Some of them do not have a biography currently posted. And so for those, I'm just going to say I couldn't pull it, and I'm just going to enter in an empty string here. So there will be no biography for this person if it had to go down that path. And here's where I'm just kind of collecting the images. So again, I'm taking the image link. I'm requesting access to that page. I then create a JPEG. I want to save these images as JPEGs. And here's where I'm writing it to my computer. So I'm just writing the content of that path to my local file system. And that's how I'm doing the web scraping of the images. And then again, I just concatenate all that information into one large table for me. So now if I view this table, now again, I have the state name, the legislator's name, their branch, their party. And if I just go here and I say legislator bio, I just want to view the first one. This was all the text contained within that PDF document. And so that's a good chunk of text that you can start building natural language processing models off of. It's not like the short descriptions that you had in Mississippi. So we'll continue to work with Georgia going forward. So that's how you web scrape. So that took a little more time than I hoped. So sorry about that. But is there any questions there as far as web scraping, that refresher? And if I go to images, now I have 2 states of data, Georgia and Mississippi. Any questions there? No? Okay, so the next thing is we're going to start, as you asked, we're going to actually build our first image classifier. So if I go back to my slides for a second, this is just some information about the 2 packages we use to web scrape those sites, some documentation on how they work, as well as how to install them. But now we're going to go to the actual thing that you wanted to come for, building an image classifier. So there are models out there called convolutional neural networks, CNN models, which are very popular for kind of classifying images based on whatever your problem set is. So if you wanted to classify them based on race and ethnicity, you can use a CNN model for that. Alternatively, if you just wanted to classify images as horses and cats or dogs, these are the type of models that we're using and how they work. So every image consists of many pixels as part of that image. And so CNN models are able to transform the pixels within the images into information about what's contained within that image. And so that numeric representation of the pixels is being able to be transformed into the different things that you're trying to predict. And so you can build many different layers on top of one another as part of this kind of set of network here that you're building. And so generally they go from being pulled at the very outer layer. You just want to pull things like, where are the borders of the images? What are the main objects of the image itself? So before you get into really the detail of the image, you're just identifying at the outer layer things like the borders and the color scheme and things like that. And then as you work your way in, you're getting more and more detailed. So you're building additional layers that kind of work through each section of the image. So here's a good picture for you. So if you have this 2-dimensional image here, So just a two-dimensional, that's going to be grayscale. If it was a colored image, there'd be 3 different kind of matrices that each would be a green matrix, blue matrix, red matrix, and that's just the different pixels. And you're just kind of working through them in chunks. So this is the most technical I'll get in this presentation, but it just takes about 3 by 3 or 2 by 2, and it just kind of works through each of those sections of the matrix, and it transforms the pixels contained within that section into this kernel, which is then able to kind of build the classifier. And you can make this as complex as you want, but the idea here is that the input is the pixels of the image, and then the output is the prediction, so the different classes that you want. So you're always going to have those two kind of ends, and then in the middle you can have it be as many different kernels or tensors as you want, depending on how what you're trying to do and how, the results of the model itself. So I'm not going to spend a whole lot of time here. We're more interested in getting this to work. But the end result is that you're able to, again, kind of label your data very quickly. And you're able to get probabilities on those estimates. And so the things you want to consider when you're doing this is the amount of time you have for building these classifiers and the amount of images you have. So the larger images, or the larger collection of images that you have, the better results you'll get, because it's able to train on a lot more data. And the better computing power you have, the faster you'll be able to do it. Now, sometimes you don't have access to GPUs for your computing, and sometimes you don't have a large image data set. So you can use a process called transferred learning to take what other models have learned to kind of speed up your process. So as I mentioned, the outer layer, the first layer of most CNN models, are just identifying the borders or the edges. You don't have to relearn that information. You can use someone else's model that has already been classified to kind of take all the weights generated from those first couple components and just reuse that information and focus more on just the very end, the thing that you are trying to solve. And so that's a process called transferred learning, and that's what we're going to kind of go over next. And you'll notice here, I did this on purpose. So this was just a different model that hasn't been retrained based on my problem set. So this is just someone else's model here, hasn't been retrained for what I'm trying to solve, but it did a fairly good job of still identifying the things I wanted to. So we have predictions for the Black legislators here at the top row. It looks like it was about 4 out of 5 in its ability to accurately make the correct prediction. White legislators here, again, it was sometimes wrong, and same with male and female. So again, this is expected because I didn't really retrain this on my own problem. I was using someone else's just to get the major weights, but it still did a decent job once I defined what kind of classes or outputs I wanted from it. And that happened very quickly. We'll go over this, but this was able to be done in just a couple minutes with a very small data set. So you can get an idea that if you were to spend more time and retrain your own model using transferred learning, you can make more accurate predictions in the future. So I will go ahead and switch back to the code here. And so the first thing I'm going to do, again, this is a transferred learning kind of assignment. I'm taking another model, which was graciously posted by Dr. Chen. And so this is just a classification model that we're going to use the initial weights from in order to kind of build our own model. And so here I'm just kind of loading in the model itself. I'm also loading just a torch vision model on ResNet. And so ResNet was trained on hundreds of thousands, if not a million images. So it's going to have the largest data set available for you for that initial weights. I'm going to then load in this additional model by Dr. Chen on top of that with additional weights. And so that's what my base model is going to start with. And here I'm just creating a function to transform the images into a numeric representation that the model can understand. So I'm resizing the image. I'm sending it to a tensor, which is just how the machine learning model works. And then I'm just normalizing the image. So normalizing the pixels of those images so that they're all standard across all the different images. So again, sometimes the color scheme might be a little different. The dimensions might be different. So this is just, depending on the image, it's gonna always standardize it into the same look that the computer can then read in to make a prediction. Here I'm gonna just map, I'm gonna encode what I want the predictions to look like. So 0 is gonna be a white politician, Black, Hispanic, and Asian. So these are the four, for this exercise, the four that we're gonna just be interested in predicting. I'm going to do the same with sexual orientation, male or female here. This is just based on image, so we'll go over, I guess, non-binary going with their biographies, but for the image itself, we're just going to keep it simple and do male and female. And here's just kind of where I'm going to remap the images into the folder that the model makes the prediction for. So the next thing I'm going to do, I'm just going to loop through and I'm going to collect the probabilities of the prediction, as well as the predicted race and ethnicity and the predicted sexual orientation. And then I'm going to just create a column here that says that if the prediction, if that probability isn't high enough to really be confident in, I'm going to flag it for manual review. So that way I can quickly see which ones the model didn't do a good job on up front. Next thing I'm going to do, I'm going to loop through all the images in my folder. I'm going to then transform it again to a numeric representation that could then be fed into the model. The 3 here indicates that these are colored images. They're not black and white. And then this is the size that I want the image to be. So I'm going to just standardize it all to a 224 by 224 image. And then I'm going to send it to the model itself. So then here I'm just making the prediction based on the image and the model I'm using. And then here's where I'm actually doing some conversions of those predictions into the assigned race and ethnicity. So again, I said that the model is going to have predictions based on probabilities of its prediction. Here, I'm going to just say what how I want to associate those probabilities. So if it's just taking the max of them for this assignment. So if the max probability was predicted race of white, that's where that's coming from. It's looking at all the different probabilities that the model output and then taking the max to assign the race and ethnicity for the prediction. And I'm going to go ahead and do that for all of those images, as well as, again, the sex of the legislator. And then if it's the probability of that guess, so if it was under 50 for the max, I'm going to flag it as the model wasn't too confident. Even the largest assigned probability was under a 50% chance. So I'm going to manually review that. So I'll go ahead and I'll run that now. Again, this just takes a couple minutes, not even, it takes, what am I saying? Maybe like 2 minutes to run. But here in the next function, here's where we're going to display each of the images and the prediction from the model. So it's just looping through and it's going to create a five column image of the 5 different legislators' predictions by the different classes or prediction types that I'm trying to identify. The next thing I'm going to do is I'm going to actually go ahead once they've made the predictions. I just want to, again, sample 5 of them from each of the different classes. We'll just focus on black, white, male, and female. And we're going to take 5 of those predictions to visualize. The next thing here, this is just preparing again, this is where I'm kind of generating what the prediction was, what the label is. And the last couple of beats of code are just to kind of append all those together. So, so the model has already run through all the different images within Georgia. So now you can see that my folder structure has been replaced here. So instead of the images appearing here, it's now within folders of their assigned predictions. So if I go to black, this is how the model perceived each of these images, the race and ethnicity, based on their headshot. And again, I didn't do any fine tuning of this model. So this model was originally trained to do something else. I wanted to train it to do race and ethnicity predictions. And so you can see that for the most part, it did a fairly good job, but there are false predictions within here. And so you'll want to kind of look at your results from the table, which shows which ones were the false predictions quickly, so you can identify them up front. So if I were to just go here, I just kind of view my results. And I'll pause here for questions. And we're not going to get to it in this, but sorry, I do have at the end of here how you would go about retraining this model to actually, if you have a collection of images and you want to get better performance on those, you can retrain it using this function down here. And so at the very end of the step 6, I kind of walk through how you would retrain a model to get better performance. And again, this would take longer than we can do in a presentation, but it does show you how you can use a base model which has initial weights and then kind of iterate through that many different times on a much larger set of data to generate better predictions. But we won't have time to cover that, but it is in here if you want to take a look for future use. Yep. Was there a question?
Yeah, Andy, this is great. Thank you. So I was wondering how you might incorporate like some of that biographical information to help the predictions. So
Exactly.
yeah. So oftentimes as a hand coder, we might incorporate something like having gone to a particular type of school or being a part of a particular organization as an indicator. So
Sure.
with that biography string, could you pull out particular pieces from the string?
Absolutely. And so the next bits of code, and I know we only have 15 minutes left, so I'm going to quickly go through that. Apologies for that. But yes, this is only step 1. Most of the time when you're building these models, you wouldn't want to just build all of your prediction based on the image itself.
Mm-hmm.
You can certainly get more information based on how the person perceives themselves, such as their gender identity and things like that, that the image might not give the best prediction for. And so this was one component of that, but you can build ensemble models, which take the image prediction, which take the biography information, takes all that information, what states they're coming from, because that might be a predictor on what the race or ethnicity of the legislator is, all that different information that's out there, and kind of combine them into one final model that you then use to make the final prediction. But the image is certainly a good step for one of those kind of pieces to unlocking that information.
Gotcha. And I wanted to flag a question in the chat from Andrew. Andrew, did you want me to read your question, or did you want to read it yourself or say it yourself?
So I'm just curious about where if this classifier had training data on images already in order to determine who is Black, who is white, who's Asian, who's Hispanic.
Yeah, so the ResNet one was not trained to do that. That was trained on, I believe it was Flickr images. So just headshots of people that are just legislators, but of all different occupations, just anyone who was on a public profile who had images. It's a public data set. So that was the first layer that we used to kind of get the information from that kind of makes up a human face. The second one was a race and ethnicity classifier by Dr. Chen. I believe they use similar information, and I have a link to her GitHub. And so you can find more information about this specific model. And I didn't mention this at the beginning, but one of the reasons why our kind of iteration of this did not perform as well as what you're seeing on her GitHub is that she also uses another package called dlib, and that requires C++, which is I was assuming that most people wouldn't have for this presentation, but what that's going to do is not only look at the headshot itself, but it's going to really only take the piece that we care about. So most of a headshot isn't actually of the face. It also includes the upper body. And that information is just kind of noise for an image or a race and ethnicity classifier. So if you were to really build out her exact model, you would want to take that second or that first piece, which just kind of isolates the face. So that will then just extract that portion of it to then send to the model. So the one that we did in quickly was just a quick iteration of that, which again has a lot of noise that might be causing some of the probability problems. Now, having said that, again, even if you did do that step, it's not gonna have it does well for a first step, but if you really wanted to use this, I would definitely recommend using the second piece with your own collection of data, which is in step 9, to retrain this and fine tune it to get even better predictions. So if you were to run this on just a handful of states, it would on CPU computing, it would probably take a couple hours to run. But I would definitely advise, again, as with any sort of data set or problem you're trying to solve, the more data you have, the better. So, but you can use the web scraping portions. A lot of the states are going to be similarly structured. So that will help you build out your data set to kind of refine that training.
Great, thanks.
Yep. Okay, well, yeah, so we only have a couple minutes left, so I'm not going to spend a whole lot of time on this next section, but this is a quick way to quickly visualize the type of themes that are happening within text data. So they're called word clouds, and they're just going to really highlight the frequency that terms appear in different biographies. So here you see here, we just looped through all of the different biographies for about 200 members of Georgia's state legislator. And we took, and kind of here are the common or most frequent words within the two different parties. So quickly, I can see that she was a very prominent word within the Democratic biographies. So that might quickly tell me some information about the gender of the different members serving within the Democratic Party of Georgia, whereas the frequency that she is used within Republican biographies is much smaller here. But it also lets you do cool things like the image itself, the background. And so here you see the donkey for Democrats and the elephant for Republicans. And that to do that, you just kind of have to point to you have to save an image that you want as your background, which I have done here. So it's taking this base image, and then it's just going to put the words within that structure. And so that's a quick way to just kind of, again, identify trends that are happening across different biographies, however you have collected your data. And this is going to show you how to create those type of word images that you can use for presentations or other ways to get across what you're trying to identify, the themes you're trying to identify. So now we're going to talk about that second bit, and that's about how to use or build an NLP model to build a predictive, or to add on to your predictions. And I realize I'm now almost out of time, but if I quickly just run this here. So it's going to go through all those biographies that we had for Georgia. And we're using a process called, well, first, to identify sexual orientation or gender identity, there's a package within sklearn, which is a count vectorizer. And so it's really just counting the number of times a word appears within the document and then creating a frequency based on those counts. So for gender identity, what I'm doing here is I'm looking for occurrences of her or she. For male, it would be he, him, or his, and non-binary, they or their. And so I'm just looking if those words appear within the biography, and then I'm comparing the frequency that they occurred within each of the different biographies. So I'm going to assign a sexual orientation or gender identity of female if he or her or she appeared as the most frequent pronoun within each individual legislator's biography. I'll do the same if male, if he, him, or his was used most often within the biography, and same with non-binary, if they or their were used more often than the other two. And so I'm using that text to quickly identify how the legislator self-identified within their own biography to kind of assign that prediction. So it's still not a kind of a classifier, but we're able to quickly identify the number of times those words appeared within the biography. Now, the last thing I'm going to do here, I'm just saying again, because I was able to identify that there are certain themes within a Democrat's biography that are separate from what's in a Republican biography. I'm going to quickly build a predictive model to see if I can identify a legislator's political party affiliation based on their biography. So that's the last thing I'm going to do here. And this is kind of where I'm training it. Here, instead of a count vectorization, I'm using a frequency, a term frequency, documentation frequency, inverse documentation frequency vectorizer. And so what this is doing is it's in a weight, the frequency of words occurring in a biography, not only by how many times they appear within an individual document or an individual's biography, but also across all the different biographies that I have in my data set. So if a term was more frequent in one individual's biography, but not so frequent in the other documents, that would tell this transformation that term was very predictive for that individual. Now, things that are more common across all the different biographies, that's going to help me identify things that make a Republican or a Democrat. So this is just transforming the words within the biographies into a numeric representation that can then be used in a predictive model. So quickly, sorry, I know I'm running over and I apologize for that. But I'm just within, like any other machine learning problem, you're going to want to create a training set and a test set. So you train the model on a certain set of data, but you hold out other data so that the model doesn't know the answer when it makes its prediction, because that's the prediction that you really care about maximizing. A model can definitely, after it's seen data many times, can very easily make the correct prediction. But on things that it hasn't seen, that shows the true value of the model that you're building. So you're just separating the data in two different training sets. Here I'm just doing some hyperparameter tuning. So I'm switching up some of the parameters of the model, and I'm going to do a random forest model to make the prediction based on the words in the biography. So that's what's happening there. Here's where I make the prediction based on the biography text. And then I'm just keeping track of the accuracy of those predictions. So if I go down here, here is kind of the distribution. Here's my results. So this was based on that count vectorization. So there were, in Georgia, based on the biographies, there are around 117 males, or people who self-identify as male, 60 females, and 4 who didn't use he or she pronouns, which we're going to say are non-binary or unknown and require further attention. So that was just based on the frequency that terms appeared in the documentation of the bio. So not really a predictive model. This is just based on the data that is self-identified. And then this section right here, this is based on the ability to predict a member's political party based on their biography. And you can see here, very quickly, I was able to get an accuracy of 86% on being able to accurately predict a legislator's political party based on their biography. And this is on the test set, so on data unseen. So that was able to quickly identify someone's party just by the words that they use to describe themselves. And again, you have things like precision, recall, and probabilities for each of those predictions that I'm not showing here, but it does have in the actual data frame. And the model predicted about 109 Republicans in Georgia and 72 Democrats just based on the biographies. So I'm going to stop there. I apologize again for having to quickly work through some of this, but I'll leave it for questions if people have it. But if not, thank you for attending the session. And I'll stay on for as long as you have questions. And again, if you were late, I do have all of this code shared in the chat. So I hope you do have the chance to kind of work through it on your own. My email is within the deck, which is also posted there. So if you have questions, please feel free to reach out.
All right. Thanks, Andy. This was really great. I'm seeing some terms that I recognize from R, so that makes me feel good.
Good, good. Yeah, absolutely. Anything I did here today can be done in R just as easily.
No, but this was super helpful. So I guess my quick question is so are there other like dictionary not libraries of photos that you might recommend, or is this like the one you use, like the ResNet one, and the other one, are they some of them?
So I would say, yeah, definitely the ResNet one is one that you definitely would want to use for almost anything you're doing, just because again, it's probably the largest collection of images. So again, you're really using that just for the initial weights for identifying the common things across all different images. So you don't want to have to do that again if you don't have to, and you don't with ResNet. You definitely don't have to start with the other trained model that I did. If you had a large enough data set to kind of just go to step 9 of this notebook and build your own image classifier from scratch, you can certainly just load ResNet and then move right into that next section here. And I didn't actually show you this, but I think I did actually. And so this block of code here, so let's say you ran the steps that I did. You're working through these images that are the predictions from that first model. And here, once you identify the ones that are incorrect, you'll just want to move the image into the right sub-dictionary. So if it was an incorrect prediction of white, that should have been black, just move the image over there. So this would just be like your initial labeled data. It's not as time consuming as doing all of it, because you have initial predictions. You can then kind of move them into the correct subfolders as needed. And once they're in the correct subfolders, this section will assume that those are the truths, or the right, the real information. And so that's going to then train based on that real information. It's going to create a new training set validation step based on those, what it's perceiving as real information, to kind of fine tune and make better predictions over time. And this actually does all the kind of moving between different folders for you. So you don't have to, again, manually do that, except for the part where at the very beginning where you're putting it in the correct subfolder. But then after that, this block of code will do all the kind of stratification into the correct folders for you. So
Thank you. And thank you again for giving your time. I really appreciate it. And if you look at the chat, folks are appreciative as well.
Oh, well, no, I enjoyed my time here. Hopefully I wasn't too long-winded. And I hope you found it somewhat informational. But again, it was a lot to cover in a short amount of time. So if you do have questions, or you want to kind of go over this in more detail, please do reach out. I'm happy to kind of assist where I can. So
Thanks, Andy. All right. I guess it's to the last of us. But yes, thank you again for your time. Very much appreciate it.
yeah, of course. Well, thank you, everyone.
Thank you.
I hope you have a good weekend and a good rest of your Friday.
Thank you, you as well. Enjoy
Thanks.
California.
Thank you. Will do.
Bye.
Bye.